Whenever you open ETABS, this shall not be the default view, because if you are connected to the internet, you will have news of the company of CSI in here. You have another window here, but since now I'm not connected to the internet, this will be the default view. So the very first thing to do is to go there and to press on a new model. Now when you press on a new model, and you wait for a while, comes the initialization of your project. How do you want me to start? By your default settings, by settings that are used in another model somewhere, or let me do my settings now. I want my units to be metric SI. I want my steel section database to be by the Eurocode. I want my steel design code to be by Eurocode as well, and the concrete design to be by the Eurocode as well. And then I press OK. Now a new window will appear. It asks you automatically, how do you want me to start? By a steel deck, by trusses, by flat slabs, waffle slabs, many options. I usually start by a grid, and I build my system inside it. Now it will ask you, how many grids in the X direction do you want? How much is the spacing between them all? Well, I need 1, 2, 3, 4, 5, 6 in X direction, and I need 4 in Y direction. So at first I'll press 6, I'll press at 4. And for the numbers of stories, since our structure is a symmetrical one, is a simple one, so we have only 2 stories or floors, and the typical height of them is 3,000 something. 6. So 3.6, and the bottom one is 3.6 as well. Now if you have something not like that, of course you go to custom story data and to custom grid spacing. Custom story data, if I press edit story data in here, I see, okay, I have story, the base is a 0 elevation, the first story is 3.6 and the second one is 3.6 as well, so the elevation at the top of it will be 7.2 meters. If you want to change something, you can change it here. I don't. I'll go to custom grid spacing and edit grid data. Those are the values, the automatic values of ETABS. Now I want to change them. You can either change by ordinates or by spacings. I like spacings. Let's go to spacing. So the first spacing in X is 2 meters, I think. 2, then 10, then 5, then 3, then 1. So 2 meters. Then 10, then 5, then 3, then 1. You have to add the last one that has to be a 0. Okay? If you forget this one, it will neglect the last axis. And in here, we have 6, 6, 6. Or we can have 2, 2, 2, 2, 2, 2, which will be easier for drawing the ribs. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it's going to be, I'll press add, and then in here I need 2, 2, 2. This is the first 6. This is the second 6. And then 2 adds. This is the last 6, and this is the 0 that I need. Okay? Yes?
But the horizontal is 5 columns, not 6.
Where? Yes, the last one is going to be a cantilever. So I need a grid for that. You will see how to do it. So I'll press OK. And OK. Now ETABS opens for you 2 windows together beside each other. A 3D one and another one that is whatever it is. Plan, elevation. Is it? Okay, it's visible. So mainly I don't want the 3D one. I can open it whenever I want. I don't want it. At the very beginning I'll save my works. At the desktop, let it be M. On the left you have the drawing orders. Drawing a slab, drawing a beam, drawing a column, drawing. All the drawing orders are on the left. And the snap and the selection are on the left bottom in here. Snap tools and selection and then. Now ETABS and SAP and SAFE works like this. You start with define, and then you draw, and then you assign your sections, and then you do your analysis, and then you see the results, and then you design. So it's exactly in order in here. Okay? So the very first step to do in every structural program as well is to define your material. So I'll go to define material properties. It has 4 default American materials that you even can't delete. So neglect them. You add new material. I want it to be by the Euro standards. I want it to be concrete. I want it to be C what? 40, 35, 45, so I want it to be 40 as our project is. Okay. 35. Okay, then 35. Then add the new material, Europe concrete, it's 35. Okay. It takes all the properties automatically. Don't care about it. So, okay, now add the new material. I want it to be steel. And I want it to be S355. And okay. If you want to define rebars, then you go to rebars. It doesn't have automatically definition. You have to define it by yourself, by the user. So you say, okay, and then you define the FY, the FU, blah, 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 blah. I don't need rebars for now. So I'll close this one and I'll save. Now I want to define sections. Section properties. You can define frame sections, you can define tendon, you can define slabs and decks. And you remember what decks? I told you if you have a deck slab in composite design. Our slab now is a flat one, is a slab. Wall, reinforcement bars, many things. I want a frame section. And you can see there are thousands of them in here. I don't want them all. Delete multiple. You can't delete them all, so you have to keep some. Delete, okay. Now it will tell you I can't delete them all. You must keep one. So it kept this one for me. Okay, thank you. Import new properties. Steel. Now it opens for you the Euro database, the Euro tables. What the material do you want it for your sections? Oh come on, it's not assigned there. Define material. What's wrong with you? Okay, and then okay. That the new material. It's going to be concrete. 35. Okay, okay, and okay, and save. Once again, define section properties, material section. Oh, that's why I hate ETABS, honestly. I prefer robot. So import new properties. I want it to be steel. And from the Euro database, and I want the material to be S355. Now you have steel I wide flanges. It means IP or HE. It's something. Channel is the UPN. T angle, blah, 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 blah. So I want I wide flanges. I want HEB 220 because it's for the ribs as we found manually. I want HEB 300. I want HEB 340, and that's it. Then I press OK. Then define section properties slab section. I delete this one because I don't want it. And this slab one I can just modify it. So I'll name it S120 as our project. The material is C3545 and the thickness is 120 millimeters. Then OK. And OK and save. Now I can start the drawing. On the bottom right, you have something in here called one story. It means if it's one story now, that means the procedure that I'm going to make, it will be only in this story. But if you pressed all stories and then you draw the beam in here, for example, then it will be drawn for the whole story. So this is a good thing. But if you've forgotten it one time, you will have beams on beams and fixes, and who cares? So I keep it on one story because it's safer. And I'll go to draw columns. This selection, quick draw columns, and it has a red dot on the order. Can you see it? In here there is a red dot. And those two, for example, this one has a red dot and this one does not. The red dot, everything with the red dot means that I will draw it automatically for you at the grid points. For example, if I've taken this column and if I've opened it like this, it will be automatically spread. I don't want to do that for now. And for the beam, the same. Well, if you've taken this one, then you have to define points. Grid, 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 and then that. So I start with the columns. How was our columns orientation? Those were to the right, and those, all of them are to the right. So I take the columns. I have a column here, and the column here, and the column here, and the column here, and here. And in here, and in here, and in here. Now I'll draw the beams. B2 was HEB 340, if I'm not mistaken, this one. Then from here to here, and to here, and to here, and to here. And if you've drawn it to the end in here without a column, it will understand it automatically that this is a cantilever. Now I can continue drawing, or I can replicate it. So I go to select, select, properties, frame section, HEB 340s, it has selected it. Now I go to replicate, edit, replicate. Do you want it to copy by a linear line, radial line, mirror, or by stories? First I want to copy it linearly. And how many times? I want it 1, 2, 3. From where to where? Pick 2 points. So from here to here, and apply. There are my beams. Now I'll save it. I'll draw the other beams, which are the 300. Once again, I can select them like this as well, and the replicate shortcut is Ctrl R. And then I'll pick 2 points on the model from here to here, and apply. I've pressed 3 times, Ctrl Z, and it's only 1 time. And the previous selection, this one is previous selection. The last time you were selecting previous selection, it's not selecting it, fuck it. Then apply. And then once again, those from pick 2 points on the model to here and apply. Once again, select those, pick 2 points from here to here and apply. Pick 2 points from here to here and apply. That's it. Now I save my works. Now a very important thing that I forgot to tell you about is when you're drawing a column, and in here you see something. This is the section that I'm using. Seems like I've used, okay, for the columns HEA 450. And there is this option continuous. What does this continuous mean? If you have a system that is a moment resisting frames system, like here, then you have to keep it as continuous. And our project is a moment resisting frames project. That's why we have hunches in here. So it's a moment resisting frame one. In case if it was not a moment resisting frames and your lateral loads are resisted by shear loads, then you draw your columns as pinned. You have the same option in case of beams, continuous or pinned. Now when I'm going to draw the rib, I'm going to draw it a pin, because it's a pinned sides, the rib, but the beams are continuous. So now for drawing the rib, I'm going to draw the beam by HEB 200, and this one is going to be a pinned. And I want it to be from here to here, 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 from here to here. And that's it. Now I save my works. I can check my visibility or my drawings in 3D, and I can do the 3D or the section extrude, so you can see your structure for real. And you can change the colors of display, so these colors are depending on the object. So that means beams and columns are blue. I can assign it to section properties and apply. So the columns and this section is gray, this one is pink, this one is yellow. Who cares? I keep it as objects, apply, and OK. Now I go back to plan. I was drawing on story 2, and OK, and I'll turn off the extrude. I'll save it. What was the column of ours? Geometry. I'm not sure. I want to check it. Let's go back to 3D. So it's HEA 450. I don't care about it for now because ETABS doesn't design composite columns, only composite beams. So I'll go back to the plan and I will draw my slab. And drawing the slab is either by this one or this one or this one, anyone you want. I can take this one, and my slab has the same thickness for the whole plan. I have the same thickness, I have the same load, I have everything. So I can draw only one slab. But you can draw a slab here. You can draw a slab here and here and here and here and here and here, like in your project. But you can draw only one span for the whole plan, like I'm going to do. From here to the end of the rib, and in here, and in here, and in there as well. This is the slab. Now what's wrong? I have drawn it as a deck. That is a mistake. So I delete it. I go back to drawing the slab. And I choose the section of mine that is S120. Then I'll draw it from here. Now I'll save my works. Now I will select everything. Now go to Control R, story 1, because I want to replicate them from story 2 to story 1. And I'll press apply, and OK, and then I'll go to 3D, and you can see your dear structure in here. And I'll turn on the extrude. Now the base restraint joints are automatically taken as pinned. And if you want to change them, you go to plan, base, apply, okay. You choose them all, you assign joint, restraint, I want it a fix, apply, and okay. I'll go back to 3D, now they are fixed as you can see. Now I will apply my loads on the slab. Remember, you don't have to assign the self-weights in your structural engineering programs because they take the self-weight automatically. So I'm only going to assign the dead surfacing load, that was 3 kN per square meter, and I'm going to assign the live loads. So first you have to define them. And in ETABS and SAP and SAFE, you always have automatically defined dead and live loads. So I go to define, load cases or load patterns. You already have dead and live, and you can see the dead. In the dead, the self-weight multiplier is 1. That means the self-weight is included in this load, this dead load. This is the live. If you want to add new loads, you have wind, you have seismic, you have construction, snow, everything. So I already have them automatically. Thank you. Okay. So I only have to assign them now. I will choose my slabs. Now be careful, when you use this select window, you select everything in the structure. So even if I was on the story 2, for example, and I have made select object, you can select by object type, column, beam, brace, whatever, or you can select by the section, select properties, frame section, HEB 200B. So you think that you have selected only the ones on this plan, but you originally selected every rib in the structure. So this select window is for the whole structure. So now I will use it for my slabs. Select, properties, slab section, select this one for me, and it's selected. Now I go to assign. Now I will assign the load on this slab. So assign shell loads and then uniform. It will tell me what load are you assigning, dead or live. I'm assigning dead. How much? 3. Why 3, not negative 3? Because look at the direction, it's to gravity. So it's already to the bottom. So you assign 3 to the gravity. If I have assigned -3, it will go up. I wanted 3 and it's dead. And be careful of this add and replace and delete, because if you already have assigned the dead load on a slab and you are going to assign a new one, if you add replace, that one will be removed. So apply, and then previous selection, and then live loads, and it's going to be 3 as well, and then apply, and OK. I'll save it. And now I'll go to define, load combinations, I want add a new combo. I will name it 1.35 DL plus 1.5 LL, and the dead is factored by 135. Add, I want the live to be factored by 1.5, and OK. Add a new combo. It's going to be DL plus LL. Forget about this linear thing because it's related either to seismic or non-linear actions, or so keep it as a linear one. And the dead and the live are both of them with one factor. And then OK and OK. I'll save my works. Now everything until now is the same in every structural engineering program. You draw your columns, your beams, your everything. Now starts the new thing. I'll go to a plan, or without going to a plan, I will select all my beams. Select properties or object type beams. It will select everything for me. I want them all to be composite, so I go to design, override frame design procedure. I want it to be a composite beam, please. Here it says composite column, but it doesn't do it. So composite beam design, I want them all to be composite beams. Now I will save my works and I will analyze the system. Run analysis, it will do the calculations for you. You wait for a while and then it will show you the deformed shape of the structure. So your structure shall look like this when it's deformed. And you can see the values. You can now, okay, checking the results. This is the deformed shape. I press on it. How do you want me to show you the deformation from where? From a case or a combination? From a combination, which is 4 deformations, and I want it to be apply. Draw contours and objects. I want the displacement to be towards Z and apply. So this is how the structure would look like. Now, in case you have a good video card, you can go to options, graphics mode, DirectX, and wait for a while. Now the display will be better now. So this is how the structure will deform. This is exactly the maximum point of deformation. And you can see the values below. The blue one is a 0 almost, and this very purple one is 22 millimeters. So the maximum deflection in here is 22 millimeters. And if you remember somewhere in our calculation in the RIP, I don't know, I'm not sure if it was like that or not. Now, I don't want to see the deformed shape. I want to see the bending moment diagrams, for example. So I'll go to this forces thing. What do you want to see? Moment 3 is around Z. Moment 2 is around Y. So I want moment 2 from the combination. This is the ultimate one. Fill diagram and apply. These are the bending moments diagram. And those are the 3 around Y. Those are around Y, and the moment 2 are around Z. So these are the bending moment diagrams of your structure. Now, to know if you really have a pinned rib in here, as we remember, in the rib we should not have negative moments. So we don't have negative moments here. They are 0, that is pinned. While in beams, we have negative moments, as you can see. And in columns as well, because in columns they are moment resisting frames columns. So we have bending moments as well. So it's the Y moment.
How do we get the maximum, min and max?
No. You have to keep checking. That will be got not from the diagram, but from the maps. The shell stresses in here you have M max and M minimum, but it will be a contour, not a diagram like this one. Yes. Now I'll save my works. I'll go to my plan, story 2 for example. I don't want to see anything. Come on. I'll turn off this view, graphics mode. I'll go back to the standard one. I'll save my works. Now I will select my beams, select object types again and beams, and select. Now the design windows are here. This one is for design steel, design concrete, design composite columns, which I hate. design trusses and steel joints, and design shear walls, and design steel connections. But in steel connections, it's very stupid. So I will go to design steel beams, and you press on this very small arrow to see your options. First, view revise preferences. You open it. At the bottom, what is the design code that you want to use for composite structures? Ours is the Eurocode 4. Now, short construction. Is your construction, does it have scaffolding or not? Yes, it does in our project. Shear studs. The minimum ratio for your shear studs contribution. Do you remember this one? It was new minimum. So it's 0.4 in the Eurocode usual. And the maximum one is 100, of course. And the single segment of shear studs, no, it's not a single segment, because if my beam is going to be continuous, I want you to put many segments, not just a single segment. Maximum longitudinal, this one is for the longitudinal, and which is SL. So there is a minimum value for that and a maximum value for that. So the minimum value is almost 80 millimeters. And the maximum is 250, for example. It was 300, I think, in our project. Yes, we took 200. So in here, you only put the minimum and the maximum one. The transphasal spacing millimeter. What is this, do you think? It's B0, this one. This is B0, this is the minimum value. So it has to be B0 minimum. So it was in our project 60, if I'm not mistaken. The maximum shear studs per row. We have 2. The camber, do you want a camber or not? No. Do you know what is a camber? A camber is that pre-deflection model. So when you build your beam, you don't build it straightly. You build it with a very, very, very small arc to the top. So when it deflects, it will return to be just horizontal. We're not going to consider camber. Deflection, the super dead loads deflection is going to be L over 200, like we've taken. And for the live loads, it's L over 400. The camber, I don't care about it. The pre-composite dead limit, I don't want it as well. I'll keep everything as well. Vibration, we don't have vibration. Prices, I don't want it to comprise the prices for me. I don't know what is that. These countries things, it's the gamma M1, gamma M2, gamma M, gamma pi, gamma, they are automatically taken as the Eurocode. So you don't change anything as well. You just press OK. And now once again, I go here, revise overrides, restrict beam, the beam, restrict the beam, no, the max. Those are for if you have a specific values in your mind for your beam. But keep them all as automatically taken. So since your material is 355, it's going to be your FY, your FU, your FU, and then. So I keep those as automatically. So I press OK. And now all I have to do is press on this one. Or pressing this one and start design check. So start design check. But I forgot something I'll tell you about now, which is assigning the design combinations. Select design combinations. So for the construction, I don't care about the construction. The strength, I want this combination. And for the deflection, I want this combination. And OK. I'll save my works and I'll do the design again. Now everything is almost full safe. Now what is green is in this area between 0.5 to 0.7, the ratio of it. And what is in blue is in between 0 and 0.5. Now how to see how many shear studs do you have? You press on every beam you want, like this one for example, right click, and you see you need 777 shear studs. So 3 segments, and in each segment there has to be 7 rows of shear studs. So it means 777, that means 21 rows of shear studs. That means 21 multiplied 2, that is 42. And if you remember somewhere in our calculations we had this. And these are the values of the applied actions and the resistance and the ratios of it. And this ratio is for the composite behavior. It means if it was just 200%, it will be verified, but you can't take it because the minimum is it's 100%. And it has taken that already automatically in the shear stats. So okay, and I'll go to the bottom floor as well. I have almost the same results because it's a repeated floor. This is how you design a composite structure or some bunch of composite beams in ETABS. Okay, save the video.